Hello, everyone, and a warm welcome. Thank you all for joining us, and it's wonderful to see that you joined us for today's webinar, Shaping Tomorrow's QA. My name is Anissa, and I will be your moderator for this session. I promise to keep my part as brief as possible. The spotlight is today on our speakers and their insight. In the next hour, we will be exploring different topics, including how AI is transforming quality assurance, system verification, strategic vision in this area, our API test generation tool used in action, and some examples on how Gen AI is being applied in quality assurance. And we will wrap this up with a Q&A session, so please feel free to share your questions that we can cover along the way. Now I would like to introduce our presenters, Alisa, Adha, and Deepika, but I'll let them introduce themselves in their turn. So Alisa, let's start with you.
Thank you, Anissa. And also from my side, welcome everyone. I hope you will enjoy the session. Imagine this. It is a release day and your platform just released to million of users in, let's say, 12 languages across 4 continents, multiple countries, and you didn't have to write or execute, not even a single regression test. The AI did it for you. It mapped your APIs, checked your coverage, predicted defects, and while you slept, your release validated itself. So this sounds amazing and a little bit unrealistic. But the real question is, did AI verify what really matters? Did it understand why this feature that we are releasing exists? Did it challenge the decision that made a perfect sense on a paper, but no sense to end users? Did it stop release, not just because of the failed test, but because of the failed mission? So the answer is no. And this is where we, as a QA, come in. Not as a testers of code, but as a testers of meaning, of trust and logic. And the AI is our assistance. We are all hearing the theories, stories, and stuff like QA is disappearing. And the answer to this is no. QA is not disappearing, but is changing, and it's leading. And we are shaping the tools, asking the questions, and training the artificial intelligence to care about what actually is important. And all this talking about competing and fighting against AI, it's not about this. It's about doing all things faster. Let's leave this to AI. And we, as humans, are going to do other things, smarter things, strategic things, and things that AI still cannot do. So welcome to the future of quality assurance, and let's build it together. But before we build this future, I will now introduce myself quickly. My name is Alisa Hrusic, and I work as a test manager for System Verification Sarajevo. I have 15 years of experience in software testing, with a focus on test automation most of the time. But lately, I've been cheating traditional test automation with the test management and AI. My current role is I'm basically responsible for, aside from test automation, also process improvements and managing the QA strategies and QA teams. And obviously, I'm trying to find ways to incorporate AI into our daily processes. So as our moderator said at the beginning of the presentation, as a first topic, we will talk how AI is actually transforming QA, because we all know it does. So I listed here a couple of let's say, the most interesting areas from my point of view, even though there are a lot of areas. But what I would also like to highlight is that if you want to try to use AI to change your QA processes, don't go and try to do everything at the same time. Even though AI is our helper, it still requires learning, adapting, and testing if something that we want to use does actually fit our needs. However, I will try to briefly say a couple of transformation areas here, and let's say if one of these is going to be interested to you and if it's going to encourage you to try to use in your projects. So for transformation area, let's call it like that, is a defect prediction. And a couple of years ago, this was something that actually was just like imagination to all of us, to have a system that is actually going to predict the defects so we are saved or having bugs, errors and stuff like that in a production. So with the help of AI, this is possible to do. So what is the approach? Well, basically, there is a lot of approaches, but it also depends on how your application is built. How do you store your data? How do you store your previous reported bugs and stuff like that? Because for AI, data is everything. But for example, how it can be is that AI analyzes historical data to predict defects that might occur. So, for example, if you are releasing versions for mobile apps, and we all know how hard it is to test mobile apps and to support all different versions. And let's say that your AI systems analyze the previous bug reports. It takes into consideration the code changes and the test coverage, and it learns that every time, for example, when the payment module is updated, bugs are to appear in a checkout flow. And then next time you touch that code, AI can alert you, hey, you should test this even better because a bug can occur here. And I know that probably we will know that from our previous experience, we don't need the AI to tell us that is a, let's say, risky area. But if we are dealing with the hard and frequent releases and we are humans, it's completely expected that we can forget something. So let's move into the next very interesting and maybe the most important area for QAs, and this is automatic test case generation. I never met a QA person who likes to create test cases, the manual test cases, and then to translate them into automation tests. Maybe sometimes it can be interesting, sometimes not. But if you are working on a project that demand you to have a very good test case written, then this is very time consuming, and we often don't like to do that. And especially if this is followed with the writing automation tests for those. And sometimes we have a feeling that we are doing an extra work always. With the help of AI, it is possible to automatically generate based on your functional or any other specification requirements. I'm not going to talk about this section too much in my part because I have a colleague who will actually show you something like hands-on how this can be used in everyday work. Also, automated test execution, similar to the previous one that I mentioned, very powerful thing that we should try to use in our daily processes. I will also leave this together with the test case generation for my colleague to say something about that. Then let's move in the next area of help, and this is the test data generation. When we are testing, especially some websites or mobile apps that are available for millions of users, very often we need to generate test data. And when we start the testing, we are very enthusiastic and we prepare some scenarios with some data that are very relevant and very like a real data, but from time to time, because we need to do regression very often, then we usually use data like test name 1, test name 1, test name 112, and similar. And then in the end, we generate a dirty data that is not as much as valuable like a real data. So, and this is very simple actually to incorporate in everyday work, because we can use AI to generate test data for us in a very easy way. And then talking about something that is also very, very interesting and very useful is performance optimization. AI can identify bottlenecks and suggest improvements. And we know that performance testing is always hard to maintain, to execute, and also to track all bottlenecks or slow responses on time. Even though the test results sometimes are very good, in some cases, we may have the experience that even though our test reports are good, we have users complaining about the performance. So it would be very good to have the AI that could identify the bottleneck. For example, to spot that database queries are taking longer than expected during peak hours. And then the AI that suggests that solution for optimizing specific queries or increasing server capacity during the traffic periods. Because the suggestion how to improve performance is also very, very important. Analyzing performance reports and also optimizing those is the hardest part that takes in the performance testing in itself. So we can obviously say that the shift has begun and we are living in the age of QA. So we can now move and talk about that. I would also like to say a couple of things about self-healing mechanisms in our automation test executions. I am sure that many of the QA engineers who had the opportunity to work as a test automation engineers have experience with, let's say, Selenium. We know that Playwright is now also very popular. And we also know how painful can be from time to time to update the tests and then to be on track with every change. When I was working in a test automation, the hardest part, or at least the part that I hated the most, was when I need to fix my tests that fail because of some, let's say, HTML change that didn't affect the functionality. One simple example to this is, for example, you had a requirement to change sign-in button to login button for some reason, product owner request and stuff like that. So you would expect that sign-in functionality followed with all other functionalities that you are testing in your test works perfectly. But your test fails because of this login to sign-in change. It still requires your time to validate the results, to note that nothing is really broken, to fix the test, to push that to your repository, and then again to run the tests. In this case, it would be very good if the test itself could know that this is something that should not break the test. And this is called a self-healing mechanism. So I will give you two examples how this can be done with, as I already mentioned, most popular Playwright and Selenium frameworks. Playwright itself, it still doesn't has the, let's call, internal mechanism in terms of some kind of library that will you just reuse. But you can create your own by using LLMs and then to use that as an addition to your test automation framework. Selenium has its own library, currently developed only for Java projects, but I'm expecting that they will release this library for all other languages and platforms very soon. The library has very symbolic name. It's called Helenium. And basically for your Java project, you only need to install the dependency. So both approaches are the same and they work by analyzing history of DOM changes, but analyzing other locators around your specific locator used in your test. So if you, for example, have this sign-in, login change, if you have a LLM or if you use the suggested library, it will only check if this is text, if text is the only change. If no other things around your tags and locators in HTML is changed. If this is the case, then your solution, your AI solution will assume, okay, this is expected. I will now update the locator and the test will pass. There are a lot of questions about this, like how do we trust self-healing mechanisms? And the topic around this is very large. We could maybe have another webinars on this topic. But I highly encourage you to try to use any of these approaches in your project to see if it will work and how. And now that we finish this, let's say, the advice and the practical example, how we can start using AI in a very easy way, let's now change the direction of talking. I'm here talking all the time about how AI can help QA, how can save our time and stuff like that. But we have also other direction, and this direction is how actually we as a QAs should test AI systems. And this is very new area for all of the QA engineers, and it requires a shift and it requires a lot of learning and overcoming a lot of challenges. On this slide, we can see 4 challenges, like the hardest one, but there are also very much other challenges around this topic. So let's just briefly, I will select a couple of them to talk. The first and the biggest challenge, not just from the QA perspective, but generally from the perspective of developing AI systems, is that AI systems are non-deterministics. So whatever worked today, it might not work tomorrow, and that still can be okay. So this is the biggest challenge. We as a QA knows that test results are passed or failed, green or red. But with the AI system, this is not the case. So we need to involve the probability in our test and say this test is passing not 100%, but let's say 84%, and we are or not okay with that. So probability now needs to be included in the test results. Then let's talk about the data. Data is everything for AI systems because data is something from what AI systems are learning. And before, as a QAs, we use the data to test our application, but this is no longer case. We need to be aware the data is now part of the application, and we need to learn from where the data is coming and how that can affect our systems. Also, we need to adapt to continuous learning of our application, not in terms of learning new tools and stuff like that. You may think you know your application perfectly, you can close your eyes and find bugs or validate some cases. But with the AI, this is different because data is the part of the application and you need to see how application will behave when data changes. And you can have a perfect code, but if the data is not correct, you will still need to learn how data affects the system. And the last, and I would say the most difficult one is how to adapt and change the QA mindset. We are humans. When we learn something, we are proud of that. In some areas, we want to improve, but when we reach some level, we are happy with our knowledge and we want to do that, what we know. But with the AI being here, and it is here, we cannot fight against it. We need to change our mindset. We need to accept what is coming and then lead towards new challenges and stuff that AI will bring. So now we can compare a little bit the old systems, the new systems, and what we expect tomorrow. So what QA was yesterday, what QA is today, and what QA will be tomorrow. So basically, we are living in the, let's say, revolution of the QA. And I already mentioned that we will need to change our mindsets, we will need to change. We will need to align to the new tools and so on. So I don't have that much time to go each by each step, but I will take just the first one. When we started testing a QA, let's say 15 years ago, the manual testing was must and the most important one. And then we had this, let's call it revolution with automated testing. Some of us liked that, some of us didn't, but how it ended, we needed to learn automation, like it or not. It is the same with now AI augmented quality engineering. So we will need to adapt and also to learn the new techniques. So I would say that we are no longer just catching the bugs. We need to validate behaviors and we need to learn a lot about the data. And now, when we know that we are living in a new era of QA, from testing to trust, as I mentioned, very interesting, it's going to be to show the automatic test case generation and how actually you can use and start working on that on your solution. And this solution is something that we built in system verification in-house, are trying on our different projects, and very proud about that. But I will leave my colleague, lovely Adha Hrusto, to present herself and to present all of us this solution.
Thank you, Alessandra, for that introduction. So my name is Adha, and I'm currently working as an AI engineer at System Verification. My background includes several years of experience within test automation and a doctoral degree from Lund University, where my research was focused on machine learning applications for failure detection in software systems. And actually that experience really deepened my interest in AI. And I'm mainly focused on using it to streamline and elevate QA processes. But as we look now to the future of quality assurance, a key question we are asking is actually how we can integrate AI in a meaningful way across the QA lifecycle. And I would like to say first, like, what we do at System Verification and like what is our strategic vision and how we plan to harness the power of AI to transform our QA services. So first, it is tech-driven excellence. So we are focused on leveraging emerging technologies to deliver faster, smarter, and more reliable QA services. So whether it is predictive analytics, intelligent automation, or AI-based test generation, our goal is to bring greater efficiency and precision to every stage of QA lifecycle. Then continuous learning culture. So remaining at the forefront and competitive means making innovation and learning a constant priority. And that is why we are building a culture where learning never stops, actually. So whether it is through upskilling our teams on AI tools and frameworks, investing in some dedicated research and development initiatives, or experimenting with new approaches. We are also developing AI-driven solutions in-house, ensuring we are not just consumers of innovation, but also creators. And this culture of experimentation and curiosity empowers our teams to push boundaries and turn ideas into real and scalable value. And finally, clients are like top priority for us. And as we develop new AI-driven solutions and continuously learn, that the one thing is very clear, that we can do it in isolation. Our clients are key partners in this journey, and by working closely with them through pilots, real-world testing, and constant feedback, we ensure that we are building impactful solutions. And this collaborative approach actually helps us turn innovation into practical, scalable outcomes that deliver real value aligned with actual business challenges. So now that we are outlined our strategic vision, let's actually take a look how we are putting this into action with our current portfolio of Gen AI powered QA solutions. So we have four key areas, but I will talk about two of them, or actually start because my colleague will continue. So first, unit testing. So here we are using AI to automate and accelerate test generation at the code level. So instead of engineers spending time writing tests manually, they can now shift their focus to reviewing and refining. And the service that we have developed for unit test generation is actually developed based on an open source solution that was previously called Cover Agent and now Kodo Cover. This is basically developed based on a research conducted at Meta. And the project basically utilized generative AI to automate and enhance the generation of tests, aiming to streamline development workflows. And our service that we build around this actually can be integrated directly into CI/CD pipelines, ensuring seamless adoption. And this can lead to faster bug detection, quicker releases, and a significant reduction in time to market for new features. Then API testing. So for APIs, we have built an end-to-end solution that uses Open API specification and Gen AI to automatically generate contract and system level tests. So it is scalable, adaptable, and language agnostic, making it suitable across a wide range of platforms. But most importantly, we extract actionable insights from the test results, helping teams to improve coverage and quality continuously. But before we move on to dig deeper into the more technical details of this API test workflow, I would like to actually show an example how AI is transforming QA. And I would like to show it on the example of actually API test generation. So on this slide, on the top row, we can see the traditional process. We start with the API specification, then the QA engineers spend about a week just setting up the entire framework from scratch. After that, they dedicate almost 4 weeks writing and automating test cases. And finally, only after this long journey, we have finalized tests, which means that the whole cycle takes about 5 weeks, but we can run it up to 2 months before a team can actually even start real validation and start with the test execution. But imagine that we have a company that is launching a new set of APIs for their customer portal, and their QA team had a very tight release deadline. And just setting up the framework and writing test scripts would have eaten up their entire testing window, and they are just basically stuck. And this is where AI comes in and can actually help us to improve productivity. And on the bottom row, you can see the AI-powered approach. We still begin with the API specification, but instead of weeks of setup and scripting, AI can take the specification and generate automated test cases within hours. Actually, the entire execution runs a couple of minutes, but we would still need more time, like hours or maybe a day or two, to basically include human oversight for validation and fine-tuning. So for that company that I mentioned, that would have taken 5 weeks, was cut down to 1 day. So they will be able to meet the release, but also to have a broader test coverage than ever before. So AI doesn't just make QA faster, it transforms it into a strategic enable. So instead of spending weeks on repetitive work, teams can focus on smarter testing, exploratory QA, and improving overall quality. But now let's take a look at this, our API testing workflow. Because I want to spend a little bit more time here, because this is where we actually made the most significant progress, and this workflow captures how it all comes together. So everything begins with the development team or customer, specifically the Open API specification, along with the corresponding business requirements. And these are then processed by our extractor, which builds structured API models and maps out the interdependencies between endpoints. And then we combine these with the relevant test data and feed it into the large language model that automatically generates and refines test cases. And we have mainly used so far GPT-4o, GPT 4.1, and reasoning model o3 mini. And generated test cases include both contract and system level tests, ensuring comprehensive coverage. So contract tests means that are tests that actually check the rules of communication between services. So basically, schema, like if fields exist as defined, data types match, required optional fields that are respected, and so on. And for system tests, it's basically just checking end-to-end behavior of the entire application. For example, logging in as a user, placing an order, and verifying the order appears in the order history. Okay, so now after the output of the LLM is our test models, but in a JSON format. So that is not a final deliverable, but a structured intermediate representation. And these JSON models are then transformed into executable test code, currently using C#-based automation framework. However, this framework can be flexible and can be adapted to generate code in other languages like Java, Python, or JavaScript, depending on the tech stack. The generated test code is then seamlessly integrated into the test automation framework where it's executed and results are compiled into detailed test reports. But let's take a look what are the key benefits of this approach. So first, it is speed, because it reduces the time required to go from requirements to fully automated API tests. Then accuracy, because the test logic is generated from the API specification and business rules, and coverage is both broad and relevant. Then this is scalable, and the language agnostic nature of the pipeline means it can be scaled across teams and projects regardless of tech stack. Then standardized test models and automation framework helps eliminate manual errors and maintain high quality across releases, which means consistency. And finally, we have productivity, because teams can focus on reviewing and refining rather than just writing repetitive test cases from scratch. And this AI-powered approach is already delivering some strong results in pilot programs, and we actually look forward to seeing how it makes a difference across teams and organizations. So I talked about about our AI solutions for unit testing and API testing, and my dear colleague Deepika will continue with two other projects that we are currently working within our innovation team.
Yes, thank you, Alisa and Aga, for the introduction and for setting the context of what we are trying to do here at System Verification. My name is Deepika. I've been working at System Verification since May of this year. Previously, I was a PhD student at KTH in Sweden, where I did my PhD in the area of software engineering. Specifically, I looked at how we can generate tests automatically by looking at how systems observe in the real world when users interact with these systems. And my role here at System Verification is exactly what we've been talking about so far in this webinar, which is this really interesting intersection between generative AI and quality assurance. And so, like Lisa and Ada have already mentioned, what we're really trying to do is to look at how AI-powered systems can be tested because of all the intricacies and all the caveats that Gen AI has with its non-determinism and so on. And also how we can use these really powerful models for QA, how we can use them to generate tests and so on, like we've also talked about just now. So for my part today, I will talk about two areas that we've also explored in addition to everything that we've mentioned, which is the generation of automated tests from requirements, which might be structured, unstructured, all kinds of things. And the other really interesting thread that we have started to explore also is something that we call property-based tests. Let's start with the first one, which is when we want to convert unstructured requirements, which might be expressed in all sorts of formats, such as in text documents, in Excel files, and so on. When we want to take those, when we want to take all of the domain technical data that these documents might contain into things that we can actually run our system against, which is executable tests. And what we've done so far in that direction is we've worked with the client in order to try to ingest these requirements, which in their case was in the form of Excel sheets with a lot of numbers and constraints and things that somebody painstakingly wrote, which is how we might imagine that many requirements are expressed as in all different kinds of contexts. And the other thing that we took as input was the existing test suite, which in this case happened to be expressed in C#. So what we did was that we used these requirements as Excel, and we transformed them into a little bit more pliable format, such as JSON. And then we used LLMs to try to process these further into something that is a bit more in between code and text, which if you're familiar with the behavior-driven development, you might be aware of how Gherkin works. And so what we did was that we used a generative AI model to extract all of these requirements that are expressed as text into something that's closer to code in the form of Gherkin syntax. And there we also had a loop to verify that the output that we were getting in the form of Gherkin feature files were correct. They expressed what the requirements did and so on. So we use different kinds of verification or evaluation strategies at this point to also keep checking ourselves as we go through this pipeline. And then eventually, since the goal was to generate executable tests that were automated, we used another AI model, or the same one in this case. We called the model again to transform these Gherkin files into eventually executable tests. And also in the same around the same pipeline, we had another feature that we used, which if you're aware of retrieval augmented generation, that is a way of giving your model a bit more context about your domain or about your requirements. So you can give them extra documents or extra links and so on. And that we did by giving the model this test framework, this code that was already existing in the test suite of this project. And we made use of a vector store to use the model, to give the model a bit more context about what we actually expect from it. So the idea was to get the model to generate things that are as complete as possible and as relevant as possible to the project, so that the tests could directly be integrated into the existing test suite of this project. And then you might ask why this is useful for you. And in order to answer that, we might also see that here we have a streamlined process that goes from the requirements to the eventual executable tests. And so you might not have to spend all that time writing these tests yourself. Instead, you can make use of these very powerful models that we have today to try to reason about your code and try to generate executable tests from them. And here, the other benefit that we have that we will now mention is that if my colleague can change the slide, that would be really nice. Thank you. So what we want really is to express all of these requirements that we have as executable tests. And doing so, we can make sure that we don't miss any requirements that domain experts have expressed as natural language, as unstructured formats. And then we also, doing so, we automate the generation of these tests, and we make sure that the delivery of our systems is faster and we potentially save on costs that we might have incurred if we pushed without testing properly. And now for the next thread, which is the automated generation of property-based tests from source code. This is another area that we've explored. But before we talk about this, let's first talk about what we mean by property-based tests. And in order to do that, we can first start with something that we might be familiar with, maybe not with this exact terminology, but the idea of writing unit tests using examples. So here, for example, you might have something like in your tests, if you're testing a square function, you might say something like the square of 2 should be 4, or the square of -3 should be 9. Or if you're testing the reversal of a string, you might say you might give it a string, and you might make sure, or you might assert that the reverse of the string is actually the reverse of the string. Or somewhere closer to enterprise systems, you might want to make sure that if your order is confirmed, the amount is a certain amount and the address is a legitimate address. And so here, what we are really doing with traditional ways of thinking about unit testing is using examples from the input to the output. So in all of these cases, 2, -3, cool, these are all examples that we have that we then test our system against to make sure that the example inputs are mapped to certain specific output examples. But then we have another way of thinking about this problem, which is something called property-based testing, which allows us to not have to think about specific examples, but rather think about the system as a whole. So instead of saying, well, yeah, the square of 2 should be 4 and the square of -3 should be 9, what we can instead do is think about general characteristics of the square function that should always be true, regardless of any input that we give it. So here, instead of saying the square of 2 should be 4, we could really say that the square of any number should be greater than or equal to 0. And another way of thinking about the reversal of the string is to say that, well, if you reverse a string, its length should be unchanged. And also, if you want to think about the order case, then you could say something like, if you have a confirmed order, and this could be any order in your database, if it is confirmed, its amount should be greater than 0, and also its address should be a legitimate address, which is a non-empty string. So if you look at the two sides, you see that from with the example case, we had one example that mapped to one output. But here we have all of these input examples that map to a single property, as we call it, in the output space. And that's really powerful. So our goal here within my team was to see if we could find a way to use a model to derive all of these property-based tests for us. And in order to do that, what we did was that we took some source files in the project, and this could be any project that you want to start testing, or if that project already has tests, maybe you want to start testing it using property-based tests. So what you do is you take these set of files in the project that are the source files, and you direct a generative model to look at the source code in these files, to make use of any comments or documentation that the model can find in these files, and also have other ways of thinking about what you want to generate tests for. So you might want to target code that is more complex. Maybe it has more lines of code, or maybe it has a lot of branches. So you might want to start testing that first. And you might also want to consider things that are not already covered by your test suite. If you have a test suite, that is, you might want to start testing things that are not already covered by your tests. And then you give all of that information to the model and ask the model to make use of this information in order to generate property-based tests like the ones that we saw. The output would be, in this case, a set of test files that all contain property-based tests that have tests that don't use specific input-output examples, but rather test that certain properties or characteristics of your system are true for all inputs that you might give it. And again, the question then becomes, do we really need these kind of tests? And in order to answer that, we can say that here, essentially the most important or the most challenging aspect of property-based testing, this thinking about the properties itself, can now be handled by really powerful models. So that's one more hurdle that we don't have to tackle ourselves. And here, the model can make use of all the information that it finds in the source files to generate tests itself. And then here, the benefit, or the real benefit of property-based testing is that instead of thinking about different examples, what we really do is think about our system in a different way and make sure, and these tests allow us to make sure that all of these properties that we define in these tests are held for randomly generated inputs. And this is really good news because then we can cover more edge cases that we might not think about ourselves. And also in turn, this allows us to cover more code in our system. And now I would like to invite Ada again to close this presentation, talk about more stuff.
Yes, thank you, Deepika. So as you have seen today, Gen AI is opening up exciting new possibilities across QA lifecycle, but actually the real transformation happens when we build these solutions together. So if you're interested in what we have shared today in any of our projects that we are currently running at System Verification, we are inviting you to co-create a smarter and more strategic approach to software quality. So one that delivers measurable value, drives faster releases, and brings AI-driven insights directly in the test execution. So feel free to reach out to us. So whether your goal is higher test coverage, reduce cost, or simply to move with more confidence. So we are ready to partner with you. So let's shape the future of software quality together.
Thank you, Adha. Thank you so much. Sorry if I have been a bit slow in changing some of the slides. I was too invested in listening to you, as I always learn something new. So sorry for that. Yeah, again, thanks a lot. I am also happy to see that we already have some questions in our chat. So I would like to read some of those to you, and then you can pick and choose whoever wants to answer to those. I hope that's fine. So one of the question is there a data how much AI tools have improved in QA automation? How many companies have already implemented and have been successful?
I did a short research on this a couple of days ago. And it's very hard to have a concrete data around that. But what I found that is from 2023 until today, adopted AI approach, and this is not just for QA teams, but in general for all project teams, the AI adaptation is over 100%. And I believe that this is true because it's very likely that teams are trying to incorporate this. And then on the QA side, I found that around 40% teams tried to use AI in daily processes to start new ways of working, but also found that the biggest obstacle here is that if you want to involve the AI in your current way of working, you need to have extra time to do so. So new teams starting from the beginning, starting from the scratch, are actually trying this approach. And then on the side, how actually it improved, I couldn't find that much data on this one, to be honest, or at least I didn't try it enough. But I can say that from our example that Adha showed for our solution, I am absolutely sure that the time saving is maybe the biggest and the most valuable thing that we can get from AI. So for our solution, we save time from 5 weeks in general needed to build a framework API solution from scratch and to create automation tests for mid-length Swagger API specification. We reduce that time to 1 working day. So I assume that this is the biggest go-to when it comes to AI.
Great. Thanks, Alisa. Another question. In API test workflow, have you noticed a difference in the test case generation when using different LLMs? Yeah.
Well, yes, I can take this one. So, I mean, our initiative on the API test generation actually started, I think, even 2 years ago. And at the time, I think that we had started with even GPT 3.5 versions of the models. And then we just, how we progressed with the development and how the new models were coming to the market. So we were just trying newer and newer versions of the LLMs, of course. So there is, I mean, a difference because different LLMs interpret our guidelines on how to generate test cases in a different way. So some models would provide, let's say, a larger number of test cases with, let's say, more variety than maybe some LLMs would provide smaller number of test cases and with more specific targeted testing areas. So of course there is a trade-off, but I guess that everything comes to the specific client projects and needs, and of course that can be adapted and based on the project structure and what kind of test cases are needed for the specific project to be generated.
Okay, thank you, Adha. One more question. How can we measure the quality of tests generated by AI tools? This is a good one.
Yeah, I can take it. This is, in fact, a very good question. The idea is that currently the models are really good, but they also make mistakes. And the mistakes they make now are really subtle. So you really have to be very careful when you add AI-generated code or even AI-generated tests to your system. So one recommendation is definitely having humans in the loop, where somebody reviews the code that is generated, be it code or test code or source code. The other ideas that you can also incorporate is that if you have a TDD kind or test-driven development kind of mindset, I was discussing with a colleague a few days ago, and this is really probably one of the solutions to do this, is to get the AI, or you might write tests yourself, but get the AI to generate test code before it generates source code. So the AI can work in an iteratively self-correcting manner, which is also a very good idea. And perhaps a third way of doing it is to use something like mutation analysis, where you directly inject problems or bugs in your source code, and then you run the generated tests again to see if these bugs that you've introduced, so you know that they exist, are actually caught by the tests that the AI has generated. So here, that could also be part of your iterative process. You generate some tests with AI, then you inject some bugs and do mutation analysis, and then you go and refine those tests if they don't catch these bugs. So there are all sorts of really neat ideas that can be used here. Mm-hmm. But it's a problem, but it has to be solved.
And maybe similar to that question, how do you trust self-healed tests? I think, Alisa, this was in your part.
Yes. Well, interesting one. And the most honest answer is I don't trust them completely because trusting a self-healing test is in some way like testing AI systems. We need to learn how the, for example, self-healing mechanism works as a first step. So we cannot just take it for granted and believe it completely. So also just to repeat that LLMs used to implement self-healing mechanisms, they don't just, their input is a DOM, let's say, but they don't just rely on one item, one tag, one locator in the DOM. They are actually tracking and comparing the changes, the historical changes. So the first step would be actually we really need to understand how LLM self-healing mechanism works. Then the second one, the whole idea of self-healed mechanisms, it's not to, I mean, the idea is to replace humans in that area, but at this stage, I don't think that we are completely ready. So we still need a human eye to verify, or maybe it's good to have a scores. If AI suggests something should be changed with some percentage. If that percentage is below our threshold, we won't actually accept that. And if it's below, above, then we will take it as a fix. And also, to be honest, in the UI automation tests, if only the locator is changed for some reason without any functional impact, and if self-healing mechanisms fix that locator, your test will continue smoothly. If the locator is broken and you fix it, and the functionality, if it's broken still, even with the fixed locator, your test will fail. So I suggest that the best approach is play around a little bit and to see how actually, what kind of the results you will have.
Perfect. Great. And I think we have time maybe for one short answer on which AI tools do we focus on for QA?
Maybe we can all try a little bit to answer this question. But for me, at least if I think about what I try to do with property-based testing, you can already use existing test libraries such as PyTest or unit test or hypothesis if you're working with Python, but there's also all sorts of libraries that you might use for other languages within other ecosystems. But you can use these tools and integrate your AI models on top of them. So, or have these models generate a test code that makes use of these libraries so that you can keep working within the ecosystem that you're familiar with, and that's a really good start. But apart from that, there's also the tools that we've talked about today, we've developed in-house. And there's also other tools that might be open source. Ada, you mentioned some before.
Yeah, that one was for unit testing. But I'm sure that currently there is a lot of different tools on the market for the different, even for the software development, also for the quality assurance, so for testing more specifically. But I think everything depends on what is your current need. Do you need help in your everyday tasks, or there is some specific project challenge that you want to address by using AI tools and so on? So it's really hard to say like what is the most popular one. It all comes to what is the most preferred, what you currently need the most.
Yep.
So
Great. Well, thank you, girls. I'm sure this is a topic that can be discussed for days and days to come with additional questions. So for all of those that have additional questions and would like to discuss this further, in the presentation, we have shared the LinkedIn codes or LinkedIn QR codes for each of the girls that if you want to discuss it, you can reach out, obviously, along with their emails. or you can write to us through our website, systemverification.com. This recording of this session will be sent out to everyone who registered. So maybe someone needed to leave earlier or joined a bit later. So no panic there. You will get all the good material. Thanks again. Thanks to everyone who joined this session, and until the next webinar. Have a great day.
Thank you.
Thank you. Bye.